So I won't spend any more time talking about myself, but I will talk a little bit about the company where I work, which is Levi's. How many of you have heard of us? I think hopefully everyone. So as some of you might know, Levi's, it's been around for a little while. But really, I would say we started this rule of transformation somewhat in the last decade or so when we had our new CEO, Chip Bergh, join. And one of the key priorities that he set for the company was transforming it into a company that's really setting an example both from a perspective of a good apparel company, but also just a model for a good company that cares about cultural values and sustainability and just taking social stands. And as part of that, he set a pretty clear manifesto, a part of which I'm going to share with you today, which is to be seen as the world's best apparel company and one of the best performing companies in any industry. He comes from a background in marketing, which is very data-driven. And so one of the key focuses that he set for us was for Levi's to become a data-driven company and to really focus on capabilities like machine learning to drive that transformation. Now, if this sounds like a story you've heard before, you're not alone, because this is a story for hundreds of companies out there. This is actually a graph that shows number of companies that mention AI in their, that's the blue line, that mention AI in their earnings calls. As you can see, the number was somewhere around the 80s in 2016, and it has skyrocketed since it's over 800 now. So yes, a lot of companies are trying to do that. And what's been interesting is that there's a lot of companies who are trying to apply these technologies like AI, big data, et cetera. But there's been a pretty interesting trend, which is when IDC did a survey about companies as to how these sort of initiatives are going. One of the interesting things was only about 25% of the companies responded. So there was some self-selection bias. And of those who responded, about 50% said that, or 50% of the projects had not been successful, and that there were some pretty major failures on the AI forefront. And it's a pretty common story. And when I joined Levi's 2 years ago, the key question that I was asked, which a lot of companies are asking today, are how do I get my AI initiatives to deliver benefits? And this is not going to be a story about hey, look how awesome we are. This is really going to be a story of we tried certain things which worked and tried some things that didn't work. So I mostly want to take this time to share out what we have done at Levi's to go from a place where we had somewhere to the a number of different initiatives and basically very basic reporting in place, but not a lot of data governance, for example, and a lot of outsourced vendor-driven machine learning solutions, which are not really delivering a lot of value, to where we are today, where we have about a dozen models in production, which are delivering value, and we have had a good portfolio and own a P&L that's actually delivering stuff like that. So mostly want to take this time to see if really talk about how if you are in a similar boat where you're trying to work in a company which is maybe not an AI native company as our friends from LinkedIn like to call themselves. How might one think about this transformation? So hopefully that's of interest. And seeing that most people are still not looking at their phones, I think this is of interest. So I'll continue there. So the first thing to do would be to think about, really answer the question as, do you have a solid data foundation? One of the things that happens with companies like Levi's, which have been around for so long, that data is often a byproduct of doing business, and it's not really treated as an asset. It's just treated like a just as an exhaust, right? So when you think about data governance, for example, it really exists between systems which are supposed to communicate with each other, but when you look at metadata, it's not really governed very well, right? And then you bring in a data scientist and you tell them hey, please build this model for me, deliver AI. Now, what this diagram really shows pretty clearly is that that's just the tip of the pyramid. So it's kind of based off of Maslow's hierarchy of needs. So unless you have a good solid data foundation, it's really hard to build AI solutions which will reliably work. And there's a lot of stuff in between that has to be built before you can reliably start building something that doesn't just work as a POC, but actually works in production. And that also doesn't completely burn out your data scientists. And I think one of the core principles here is to think about that data is the true asset that's powering your algorithms, right? So John Hennessy actually famously said in one of the podcasts that machine learning is the ultimate garbage in, garbage out technology. So while something might work in a POC, which has very clean data in it, to make something work reliably, you have to build a strong data foundation. So that's one of the key things, the first thing to look at when you're trying to undergo that transformation. That's one of the first things we focused on as well when I started at Levi's. The second thing, and this is something our friends from Capital One talked about, and so I'm not going to belabor the point, but I think the key thing here to note is that a lot of us, again, like similar to the hierarchy of needs slide, focus on just the machine learning code. Now that tends to be a pretty small fraction of the overall system. A lot of time and effort has to go into understanding how are the config systems being built, how is data collection being done, and how is my serving infrastructure being managed, who's responsible for when my pipeline breaks, right? Stuff like that, right? There's a lot of these things that have to be figured out before we can even think about launching something to production. And so I think this was another area to really have a lot of places when you start enterprises engineering reports into IT, right? And IT might not necessarily think about all these things versus a machine learning engineer has to. So it's important to then figure out who are the point people who are responsible for these areas as well. Not the black box is a sexy thing, everybody wants to work on that, but outside of the black box, all these gray boxes, who's the point person for that? The next thing is what we did was really went around and did stakeholder interviews. And what this looked like was actually what you probably see if you Google the word brainstorming, what it looks like. I think on Google image search that's what a lot of it looked like. We had a lot of post-its, people with preppy music playing, writing on glass walls, etc. The core thing was really asking the question of as business stakeholders running different organizations, what are the core problems that keep you up at night, and where is it that you will that you feel that data can really transform the way you're working? And it's a little bit when you ask these questions, you get two types of answers. One is the kind of person who has heard something and at TechCrunch Disrupt, or read something in HBR review or something, or Harvard Business Review, and they're like, hey, that company's doing this, I want to be doing that as well, right? So you get a lot of those kinds of answers, and it's well, is that really the right problem, or is that really the right solution? And then the second type of answers you get are very I would say pessimistic, in the sense it's very I just want something that can help me improve my sales next week. Right? Now, machine learning really can't do that very well unless you have a fully functioning system. And so then it's about finding that middle ground where it's neither way too ambitious and neither way too cautious. And so a couple of prompts that we found helpful were things like this. So you can literally put this prompt on a wall and ask people and give people post-its and ask them to fill this out, right? Which is let's say if I could identify some behavior in some data set, I could take some action, right? So it's like an add MATLAB, right, type thing where you can basically just go about and saying, if I could identify customers' churn potential in my clickstream data, I could deliver personalized promotions, let's say, to keep them on the website, right? So you can go, you get the idea. So that was part of it, and there's other ideation sites as well, and so we went through a bunch of these and got a lot of post-its, stacks of them. What was interesting that came out of it was that we found ourselves looking at really two broad categories of problems. When we talk about machine learning and AI, I think people tend to club these together. I think this was helpful for us to reframe this as one class of problems that we came up with was building data-driven products, and the other one was making data-driven decisions. Now this, I'm not sure if the distinction is very clear. I'm not sure it's talked about very commonly. So I'll spend a little bit of time right now, and then we'll dive deeper into this in a few minutes. So building data-driven products are basically, and this is your classic stuff when we think about machine learning. This is the stuff that most people think of, which is recommender systems, chatbots, search engines, etc. So these are things that you would sort of are running on the cloud, delivering let's say recommendations or search results or chatbot, whatever, stuff like that, and using machine learning and sort of updating with as the customer data comes back, right? So there's all that ecosystem there. The second one is where I find I think there's not a lot of conversation around, which is really making data-driven decisions. And this is sort of a separate field. I think some more mature companies tend to like have their own bucket for this, which is what they call decision science. I know Google and Facebook have something, but I think most companies don't. So I think it would be useful, I think, as you all think about running this in your companies, to think about what problems might fall in here. So some of these might be, let's say, around planning, right? So in cases when you have to make a decision, let's say 6 months out, are there ways that you can use data to drive that decision? Can you build some kind of forecast, right? So one of the common examples is like, Black Friday as retailers. Like some of you, the moment I say the word Black Friday, like, probably shudder in your seat. It's one of those like make or break times of the year. So, we want to do capacity forecasting, right? How many servers do we need? We don't want to be like, found serving 404 pages or time requests, right? When people try to like come on your website. So that is something where you can actually build a pretty neat forecast and help drive that decision, and where it's not just like, oh, last year we had these many requests or 1,000 requests a minute, so this year we'll just add a 20% buffer and make it 1,200. Like, a lot of places do it this way, but there's a different way of doing it, where you can actually apply machine learning to make a better decision. So we found that our problems when we did the whole like brainstorming exercise fell in these two categories. And most of the remainder of the talk, we'll talk about how we approach solving these two classes of problems. And after that, we'll also look at how we like verify if that is actually like delivering the right benefits. So hopefully that's of interest. But before that, I think the one thing here I want to talk about first is that just because somebody says I want something to be done, like doesn't mean that it's the right problem to attack, because you have to always prioritize initiatives, because I think unlike a lot of startups where it's like growth at all costs, or like machine learning is like driving the bus. I think we are just part of another org, and like we are responsible for the P&L, and we are as answerable to finance as anyone else is. So we need to be delivering value as we go along. We need to be showing ROI as we go along, otherwise we get defunded. So part of it is understanding what are the projects that we should be really focusing on. And one of the frameworks that helps us prioritize is this framework around it's like the standard like McKinsey like 2x2 like of effort impact. So basically like on the y-axis you're looking at projects which have low to high impact, and on the x-axis you have projects which have low to high effort. So you definitely don't want to be like playing around in the bottom part of the matrix, and then the pink section, the quick wins, is really where like the big value comes from. So you want like a healthy divide between the pink and the yellow section. And so we would basically plot our projects on those dimensions and see where we can drive value from. And then the other one that really comes in handy is like the Eisenhower matrix, which was actually famously pioneered by our ex-president Dwight Eisenhower, where he would basically divide it into, again, a 2x2 matrix, which was important versus urgent. So as you can imagine, when you are working in any field in technology, you get a lot of asks which seem very urgent, but they might not be very important. And I think to really drive productivity and like employee satisfaction, you have to start taking away items which are urgent but not important. So basically stuff that's over here. Oh, this doesn't have a laser, but anyway, stuff that's like at the bottom left, and really focus on like important but not urgent tasks, because that's where like the true value comes from for a company. So these can be helpful when you start looking at prioritizing initiatives. And the other way of thinking about it, which I think we have really doubled down on, is like really thinking about your project portfolio as a set of capabilities that you're building for the company. And what I mean by that is, when you're working for like a place where like a company, like an established company, like an enterprise, you have to there's a great saying, right? It's like think global, act local. You kind of like think about it like that. Similarly, where like you have to like think long term and act short term. So the idea there is that while you're working on one specific project, where you are trying to like build one application, really what you should be focusing on is to build a central capability. And so the way we think about this is that anytime we work on one specific project, we want to be looking at what kind of data is being used there. Can we make that a data asset that can be leveraged by other teams when they want to work on similar projects? And we'll talk about something we do for that later on. And then once you think about that, then can we build certain algorithms which can be like not plug and play, but maybe like 80% of the way there, so that let's say a similar team or like if a team is in some other area wants to use a similar algorithm, they can connect with other data assets and connect that algorithm and algorithmic engine. Let's say let's say we're doing recommendations for the website. Somebody wants to do a recommendation in the app. Can they like plug in the data from the app and connect it with their same recommendation engine and power that? And then finally, you want to have like an integration layer so that business logic can be integrated pretty easily. And the core idea is that as you build the foundation from the ground up, you're always you're all working together to really drive the tip of the pyramid, which are the personalized experiences. But every sort of layer is coming together to really drive sort of like this synergy between different projects. So with that, I'll actually jump directly into the building data-driven products and how we went about that at Levi's. So again, I think data-driven products fairly, I think they tend to have a pretty, again, not representative for all products, but basically tend to have this flow where you start by identifying the opportunity space, right, which is kind of starting off with somebody's gut feeling or hunch or some consumer research you have done. Then you do some exploratory data analysis to understand how big is the space, what are the key problems here. Is the data that we have actually going to solve this problem for us? Then you actually work on a model that can help you sort of solve this problem. You deploy this model in production, or hopefully, and see if it actually works. And then you want to test an experiment and see how that actually ends up delivering benefits. The experiment might tell you that part of your hunch that you had initially was correct, part of it was incorrect, and then you redefine your opportunity space and you rinse and repeat. So that's kind of like a standard flow. I mean, obviously your mileage may vary, but that's kind of how we think about it. And so one of the key principles here that we always stick to is prototyping, or actually I think one of the terms we use is prototyping, which is basically that before you write a single line of code, you want to verify that there's actually the opportunity space that you're identifying actually exists. And one of the I think the quotes that we often refer to is this by Frank Lloyd Wright, the famous architect, which was you can use an eraser on the drafting table or a sledgehammer on the construction site, right? Which one would you prefer? And so we really try to make sure that anytime we're starting off a product, a data-driven product, we are finding some way to do some kind of testing for it. And so the way we think about it is actually one of the frameworks we use is called Wizard of Oz testing. What that looks like is, I mean, how many of you have seen Wizard of Oz? Hopefully I'm not making an obscure reference here. Or actually read the book or something. So the idea there is that in Wizard of Oz there was a man behind the curtain, right? So you want to do something similar where let's say you're building a chatbot or building a recommender system, right? So what you can do is that you can have a person basically mocking what this AI would be doing and see how people react to it, right? Because that really gives you some validation of whether or not your experience when it works perfectly, how much delight is that going to create? And then the other thing is that you want to start building something in the crawl, walk, run phase where you're delivering something end to end first before you so that you can always start testing as you go along and then improve things based upon the feedback that you get. So I think this mindset is something we deeply follow when we think about building a product. So I'll give you an example how we went about this. So once upon a time we had the recommenders carousel on the website at Levi's. This was what the experience looked like. This was a couple years ago. Can anyone sort of spot any issues with it or find any weird things about it? Any guesses? Yeah, men and women's products that have men and women products are being shown together. The other thing is, so random female gene appears out of nowhere. But there's also this thing here, which is recommended for you. So if you land on the website, even on incognito browser, it'll say recommended for you. A lot of people said recommended based on what? What information is this based upon, right? And so in the world of security and data privacy, that was a big question. And there's a random female gene that appears. And then expensive products and discounted products are shown right next to each other, right? Now that's not a great experience. So why was that? We basically looked into it, and I mean this was what was happening when I joined. When it was basically calling a third-party API, and it was pretty this was the architecture, right? The website calls the third-party API. The third-party API basically sends back a recommendation. That's about it. The problem there was that there was a 24-hour gap in refreshing these recommendations. Now, put your hand up if you have browsed a website for 24 hours straight and not, I don't see any hands, so I think this is probably, the point goes across pretty easily that this is not really personalization anymore. So we looked at how can we do this better. So we looked at actually using Elasticsearch for this, where we would put all of our product information in Elasticsearch. And from us, from a theoretical perspective, a recommendation systems fall under the same sort of class of problems as search engines, which is information retrieval. So for us, a recommendation problem is a learning to rank problem. So we thought Elasticsearch is really great at that. Why don't we use it? So we used it. We had a number of issues. One was latency, like Elasticsearch was not performing to the speed that we wanted to. And the other thing was that it was hard to like add business rules on top of it, right? Where if you want to like show like constrain things like, hey, don't show discounted products on the homepage, it was hard to do that on top of Elasticsearch. So we like moved away from it. And this was V3 that we went to. Now, as you can see, it has gotten significantly more complicated. This one solved a lot of the problems. One of the issues we ran into there was even though it was actually delivering the right experience, the latency was pretty high. Like it was going up to sort of like a few seconds, like 10 to 12 seconds sometimes in latency, which wasn't great, but it was I think we could do a lot better. And the thing is like we don't want our pages to take like a page load to take 10 seconds, right? People are just gonna like go away from the website. So then to cut down the latency, we moved to a different architecture. As you can now see, it has gotten even more complicated. But this really helped us cut it down quite a bit. And this is what actually is in production today. And it's working. And like as you can see, many components. And happy to talk about this more in details. I'm getting a time warning, so I'm trying to like really power through this, push through this rather. And so this was actually working fairly well. And this is what's in production today. And what we're moving to next is this version. Now, what I think might jump out to you immediately is like how less complicated this looks compared to this. And that is actually one of the most beautiful things about when you get to build your own systems, is that you get to refactor code. Now, refactoring code might seem like a chore to some people, but that's actually one of my favorite days of the year is when I get to delete code, right? And so this is what actually we are able to do by using some of the more native applications on the cloud, and like by having a more sophisticated architecture, we were able to like delete a bunch of lines of code and actually use an infrastructure where you actually have CI/CD built into the whole workflow, right? So now you don't have to have like a person like deploying things on like a bunch of EC2 machines. Like it's all managed through Jenkins. That's awesome. And so I think this actually goes to my point of actually this paper, which is cited in the source, which talks about like evolution of code complexity. And I think one of the key findings that they have is that over time, like software products, they tend to go through this cycle where code complexity is abstracted into architecture complexity, and the number of lines of code drops, which is actually interesting. And I think a lot of products that we're building are going through this transition. And so I would say like as you're building products, like keep an eye out for complexity and like try to reduce it as much as possible at the code level and try to take it up a notch at the architecture level. I think one of the things that has really helped us like through a lot of this process, like to cut down the code complexity, is this functionality on AWS called step function. I'm not sure how many of you use step functions or AWS. Yeah, so a few hands. I mean, I come from a mechatronics background, so like anytime we talk about like state machines, I'm like really happy. So this has really helped us orchestrate a lot of our workflows, which is, I think I would highly recommend like thinking about it. The other thing that we use a lot is SageMaker. So I think a couple of people talked about SageMaker before. But one of the things that really helps us there is power, like, I think increase our productivity, is this whole idea that you can like do model development and performance testing pretty much like in a few lines of code. This is literally the code base that, like, this is all the code you need to like deploy a model and put it in production. And one of the cool things you can actually determine, sorry, I don't know if you can read this, but you can actually specify the type of server you want to deploy it on, which actually helps you like really cut down on costs and do performance testing there. That really helps. And I mean, a lot of people think of SageMaker, at least that's how I used to think of it, as like basically just like a hosted notebook, but it's so much more than that. Similarly, like you can do like model deployment as endpoint, and I believe one of the previous speakers talked about it as well, so I'm going to go into too much detail there. The other feature that actually SageMaker has, which is called ground truth, which actually like really helps you do active learning. So active learning is basically this field, sort of a subfield within like data labeling, or I don't know. It's hard to categorize this. So it's a classification problem in some ways. But basically, what it does is that you only label the examples which the machine finds it hard to. So like you can get a confidence score on every prediction. So anytime, let's say, it drops below, let's say, 70%, or whatever your appetite for human labeling is, you can actually then have a human label it, and then those examples become like training examples for the next iteration of the algorithm. And what ground truth really helps us do is that we can actually use whoever we want, whether it's like Mechanical Turk or our internal resources, to then help label these data points. And so one of the key lessons that I would say I'll take away from this is pay attention to your training data. Like I think goes without saying. Make sure it's free of biases and errors. Like that's, again, garbage in, garbage out, right? So please remember that principle. Get something working end to end right away, and then improve one thing at a time. Like every time you build a model, like build like the cheapest, dirtiest model you can. acquire a bunch of technical debt, start testing it, and then start looking through your list of future improvements based upon what consumers are really asking for, right? So because each person is going to have their own, oh, I want to do this right now. I'm doing this using KNNs. I want to be doing this using let's say LSTMs. Let's put that on the back burner right now, right? So let's start with getting something out working end to end and then improve it. Look for graceful ways of failure, of accommodating failure. I believe the speaker from Zappos talked about it as well. But basically, you want to have a way where, let's say, maybe if your pipeline breaks, you're not giving personalized recommendations, you're just giving generic recommendations, but it's still better than seeing a error 404, right? Maximum accuracy does not equate to maximum business impact, right? I think pretty obvious, but hard to always push the point across that data scientists we really care about accurate models, but sometimes the thing that drives most business value is maybe has a lower ROC than your best model. And then the other thing is think about using data efficient methods. So I think a lot of us, when you start off with a project, we use things simple, more traditional algorithms, but then we want to move to deep learning based architectures. And there it's easy to get all crazy about doing things, but I would say think about using transfer learning approaches, think about using weakly supervised approaches like Snorkel, or using active learning approaches, because these are very data efficient and can really help you get off the ground very quickly. So making data-driven decisions, I don't know if you have enough time to cover this, but I'll try to brush this pretty quickly. The main thing that I would want to stick to is this. Problems that your decision that you're trying to make, they fall on a spectrum. And you need to think about who's driving the decision. Is the decision being driven by a human and being informed by the data, or is it being driven by the machine and being informed by humans, subjective knowledge, right? And so things tend to fall in that spectrum, and you want to be using the right tool for the right job. This is an example of how we did that. We use this platform called Dataiku to do a lot of our work, and this really helps us orchestrate these workflows, and it's helps us prototype things very quickly. This is a good checklist if you want to determine is machine learning the right use case or is the tool for your decision-making process, because a lot of times people come and say, I want to be using machine learning for doing this work. Not always the right thing to use, and I think one of the best examples that I often use, which has often worked, is asking yourself this question, would you trust a pigeon to make this decision? So this is actually an example from an actual study from, I believe in UC San Diego, where they had a bunch of pigeons, a flock of 15 pigeons, make a decision. They looked at these, I'm not a cancer researcher, so I don't know what the right term for these images are, but basically these scans of a person's body, I'm guessing, or some part of their body, and then the pigeons would vote whether or not this person has cancer. And when they did what they call flock sourcing, where they averaged out the decision of the pigeons, they got to about 99% accuracy. Now, if you imagine you told your business stakeholders hey, a bunch of pigeons are making this decision, would they still be as impressed as if you said it's a machine learning decision, right? And so you want to keep that in mind, right? It's you want to see what the appetite for true automation is on their front. So I think I'll skip past this. I think A/B testing is important to test your application and see if they're actually delivering value. One of the key things here I would like to talk about is this, which is please make sure that anytime you're building a product, it's really, whether it stays on the website or stays up or it gets pulled down, it's really determined by your users and not by one of these entities. Some of the common ones is called HIPPO, which is highest paid person's opinion. And then there's Rhino, which is a really high value new opportunity person, or zero evidence but really arrogant, or works on the list fire. So there are all these creatures that you'll encounter in your workplace. Make sure they're not informing your decisions, product decisions, but really it's driven by data and your consumers' feedback. Run the A tests, stuff like that. Oh, last point, please choose your metrics very carefully when you're running A/B tests. One of the things is, I think humans are really good at coming up with metrics and gaming them, right? So this was actually an example from Soviet Russia where they measured workers' productivity on the number of nails made. So they made really tiny hair with nails. But then they said, we're going to measure your productivity on weight of nails. So they build these giant, baseball-sized nails. Neither of them were actually working. So the idea is that you want to be using the right metrics, right? No one metric will always encapsulate your business objectives. And the other thing is you want to be not fooled by sort of metrics which may look like they are giving one story, but the truth might be something else.